Hey everyone, my name is Daniel and we'll be looking into introduction to set theory. So what is set? A set is a well-defined collection of distinct objects which are called the elements or members of the set. Okay, so when we talk of a set, we are talking of collection of objects, but this object has to be well defined and they have to be distinct, right? So for example, a set of cups, a set of football players, a set of students, or a set of fruits in a basket. Okay, so this is to let us understand that a set or the object in a set has to be distinct, which means they have to be unique, they are not meant to be repeated, and they have to be well defined. So you can underline distinct objects and also well defined. So these are the two terminologies that well describes the collection of a set. Okay, it has to be well defined and it also has to be distinct objects. So these distinct objects are also called elements or members of the set. So these are the things that makes up the set. All right, so we can, for example, we have a set A in a curly bracket, 1, 2, 3. So here 1, 2, 3 are the elements of set A or the members of set A. Okay, and as we can see that the members are enclosed in a curly bracket or a braced bracket. So you can call it a curly bracket or a braced bracket. Okay, I think we all got that. So a set, the members or the elements of a set are enclosed in a curly bracket or a braced bracket. Now, there are different types of representing a set, which can be called set notation. Okay, set notation. Okay, so set notation refers to ways at which you can represent a particular set. Okay, so number one, we have roster. Or enumeration notation. Okay, number two, we have set builder notation. And number three, we have semantic definition. Okay, so we have roster or enumeration notation, we have set builders notation, we have semantic definition. Okay, now let's look into these three. All right, so for number one, which is roster or enumeration notation, row star notation also implies listing a particular set. Okay, it also implies or refers to writing out a set, okay, or writing out the elements in a set, okay, separating them by commas and enclosing them in a curly bracket, right? So we can be given, let's assume we have set A equal A E I O U. So these are the letters in a vowel. All right. So this is listed out and separated by commas. So this notation is called row star notation. So you can see that we listed them out, right, properly. All right. So this can be called row star notation or enumeration notation. Sometimes they can also be called listing method. Okay, so number 2, set builder notation. Set builder notation. Okay, so set builder notation involves representing a given set by proper description. All right, set builder notation involves representing a given set by proper description. So please, we can underline the word proper description. All right, so which means that for set builder notation, it is mandatory that we give a proper description to the set. Okay, so for example, we have a set of vowels. Let's use a set of vowels. A equal X, right? Where X is a vowel. It's a vowel. Sorry about that. Okay. Now, this is a set of vowel, right? So, if I should interpret this using listing method or row star notation, then I'll be listing out the vowels, right, as A, E, I, O, U. But now, for set builder notation, right, I'm not going to be listing, but I'm going to be giving proper description. Okay, I'm going to be giving proper description, right, to the set. All right, so here we see that A is equal X. So first of all, I attached a variable to set A, right, which is X. Then I described what X is standing for, or what X means. Okay, so I say A equal X. Now, where, so this bar is also called where, right, or such that. Okay, it's also called where or such that. Okay, so A equal X such that X is a vowel. So we can use this bar or we can use full colon, right, to describe where or such that. Okay, I think we are good with that. Okay, so we can also say B, for example, if B is equal 2, 4, 6, 8, 10. Right? Now, interpreting this in set builders notation, we are going to be saying B is equal X, where X is an even number, right? And X is less than or equal to 10. Okay, so here we have B equal 2, 4, 6, 8, 10. So these are even numbers, right? So for set builders notation, I have two ways, or I have two description to this set. I believe we are following. Okay, so I have two descriptions to this set, which is that this set is a set of even numbers. Okay, and also this set is um, is lesser or equal to 10. Okay, is lesser or equal to 10. So which means that the even number we have here, right, is lesser than 10, and it is also equal to 10. So which means that it stops at 10, right? I think that's understandable. Now let's move to the last one, which is semantic definition. Okay, so for semantic definition is almost similar to set builder. Okay, semantic definition. Okay, so semantic definition is talking about is is when we are representing a given set, or when we are defining a given set. Let me put it that way. Okay, so semantic definition is defining a given set. Okay, so which means that a given set can be defined, right? Now let's not get it confused. Set builder is describing or giving a set a proper description, but semantic definition is defining a set. So I can say that set A is equal students of Miva University. Okay, that's, or let me say whose age whose age whose age whose age is greater or equal to 25, and then I close my set. Okay, so this is an example of semantic definition, right? So I defined the set. All right, so now I can now break down the set probably by using roster notation to really describe the set, right? But this is an example of what? Semantic definition, right? So which means I am directly defining my set. All right, so let's move into types of sets. So we have let me say, I would say 6 types of sets. Okay, so if time permits us, we'll talk about them. All right, so let me just talk about the few and the simpler ones before I move into the others. Okay, so number one, I have empty set, empty or null set. Okay, so an empty set is a set that contains no element. All right, an empty set is a set that contains no element, and it is represented by a curly bracket, okay, and enclosed. It is represented by this brace bracket, which is empty, okay, or phi. Okay, so this also is called phi, and it is also called empty, right? So this is a representation of what? An empty set. Okay, like I said, this can be called phi, so phi, phi. All right, so for example, if we have A equal X, where X are males with 7 legs. Okay, so if we have this kind of a set A equal X, where X are males with 7 legs, I don't think there are males with 7 legs in this world. I don't think they exist. I'm very sure of that. So because they don't exist, then set A is empty, or I can say set A is an empty set, right? So therefore, I can say that what A is equal an empty set, or I can say A is equal phi, right? So number 2, singleton. Singleton. All right, so a singleton is simply a set that contains just one element. Okay, a singleton is a set that contains just one element. So for example, I have A equal 3. So this is an example of a singleton. And please note, if you see something like this, A equal phi, right? Okay, this is actually a singleton, not an empty set. Remember that I said that an empty set is a brace bracket without a content in it, right? Or phi, right? So it is either this or this, right, that represents an empty set. But if you have phi, an empty set, right, in a set, right, it means that this set is a singleton, right? It means that this set is what? A singleton, which means there's one member in that set. All right, so to the next, I'll be talking about finite and infinite set. Number 3,